Okay, I just wanted to do a quick video on this major problem that I've noticed with a lot of the Arduino tutorials and examples that are included with a lot of the libraries, and they all have this problem. Very few do not, but I want to say probably about 90% of them do, and it just drives me nuts. I was working on a project on the Mega that used a lot of variables that were written to a TFT screen, a lot of text being printed to the TFT screen, and a lot of sensors connected to it. And I had this big vision, and I was following all of the stuff that I learned on the tutorials, and I was running out of RAM really fast, and my project wasn't even off the ground. So I looked into the problem, and that's when I realized I was wasting a lot of memory by following what I was learning. And the problem is here. Now what we're doing, and this is just, this sketch is from an Elegoo starter kit that I bought, and by the way, it's a really good kit. Very happy with it. But it's all over the place. Tutorials online, it's all over. But the problem is we're declaring the LED pin to be pin 13. We're declaring the this is for the passive infrared sensor. Basically, it's a motion sensor for the Arduino, and we're declaring that that pin that sensor is connected to is 7. That's good, but we're using an integer to do that. That's not correct, and I'll show you why right now. If you look at the data types here, you'll see that an integer is a 16-bit data type. It's a signed number, which means it can go negative. And the value ranges, this is the value range, okay? So we're going into the thousands, negative and positive. Now, if you look at the correct data type to use, it would be a byte, which is 8-bit. That's half the memory, which is an unsigned number, which means it's positive numbers only, from 0 up to 255. That's what we want to use, because all we're doing is we're declaring the LED pin 13. 13 is between 0 and 255, as you see here, between 0 and 255. You'll never go below 0. You will never go above 255. There's not enough pins on the Arduino, whether it's the Mega, the Uno. I'm not aware of an Arduino that has more than 255 pins, for inputs and outputs, whether they be analog or digital. So why would you use a 16-bit data type to store an 8-bit value? You wouldn't. So we're going to change that right now, and we're going to make that a byte. Now, the second problem with this is they're setting up this data type here, and what they're doing is they're doing a digital read on the pin, which is going to return either a 1 or a 0. And they're storing that result, which is going to be either a 1 or a 0, by this statement here. They're storing it in here. So this is going to be either a 1 or a 0. You don't want to use an integer for that. You want to use a byte. It's the correct data type to use. 8-bit instead of 16-bit. Okay. So this is right now, right? Well, it's better, but it could still use some improvement, because now you have to ask yourself, byte LED pin 13. So what I'm doing is I'm declaring the pin 13 to be the LED pin, and I'm using the data type of byte to do so. Okay, so now instead of loading 16 and 16 into the RAM, I'm loading 8 and 8. So that's half. I'm using half the RAM. but I don't have to use any RAM, and this is why. Your LED pin 13 is not going to change. You are not going to change your program where the LED pin is going to be 13. Now the LED pin is going to be 11. Now the LED pin is going to be 0. Now it's going to be 5. You're not going to do that. Once you tell it LED pin 13, it's going to stay 13 for the entire program. So by doing this, you're telling it that it's a constant byte LED pin 13. Okay? It's constant, meaning it's not going to change. And you can do that for any data type that will not change. So if you're going to declare any kind of a constant value, that the program is not going to change that value, that's a value that you're giving it, declare it as a constant, because constants are not loaded in RAM. Now down here, since you're reading this into that value, or that right there, the value of this, which is going to return either a 1 or a 0, is stored here, which is declared up here. You do not want to declare it as a constant, because if you do, you will not be able to read this value into here. And right now, the way Arduino does it by default, if you don't give it a value, like say you don't say equals anything, this is what it's going to, Arduino is going to do this for you. It's going to automatically set it to 0. So this or that is the same thing. So, but if you were to do this and make this a constant, it would always be 0. You go to read this and store it as a 1, it's not going to change. So you don't want to do that. You just want to do that above. So now you're using 8 bits instead of 16 to store a value of 1 or 0. You're using 8 bits and 8 bits when you're declaring the pins, LED pin 13, LED pin, or PIR pin 7, but you're telling it it's a constant, so you're not loading any of this in RAM. You are loading this in RAM, but you have to, because obviously your program is going to be manipulating that. And if you have a lot of pins, like say you're using the Mega and you've got a lot of pins, that'll add up. If you're just going to declare everything as an integer, pin this, pin that, it's going to add up, especially if you're using most of the pins. So your constant byte, so you're saving flash right here. So you're also not processing 16 bits of information to read an 8-bit value. So it's more efficient programming, it's smarter programming. And the thing you got to ask yourself, going back to this, is when I need to set up a data type, when I'm going to be using a data type, what is the minimum and maximum value that is going to store, and is it going to be a negative or a positive? If you need negatives, you're going to have a signed number. Otherwise, you can use an unsigned number. But remember, when you use a signed number like this, you only have half is negative, half is positive. Whereas this is all positive, nothing's negative. So anyhow, I kind of got that off my chest. It's been bugging me to see it done the way it's been done, because technically this is the way you want to do it for saving memory, efficient programming. It's just smarter. It's correct. Way more correct than storing a 13 as an integer. So I hoped that helped everybody out. And hopefully a lot of you guys will find that useful. I will be doing more videos on the Arduino, and I'll be doing more videos on data types, and there's going to be a lot more excitement going forward as things progress. So stay tuned and check back for more updates.